So we're back to scatterplots. We're going to take another look at scatterplots, and we're going to look at them in a couple different ways. So remember that we had some different sort of correlations to look at. We had positive correlations, so if we had a whole bunch of points that were sort of trending upwards from left to right, that was positive correlation. We also had negative correlation, so if we had some points trending downward from left to right, it was negative correlation. And then, if you just sort of have random points all over the place, that is no correlation. So that's just a reminder of what we had already looked at. We also looked at being able to draw a trend line so that you could have a line of best fit. So on this graph to the left, here's the trend line, and you can see that it sort of goes through the center of the dots. We try to make it so that there's about equal distance from all the points on the top side, to the bottom side, and it also has a sort of the right angle. This is a computer-generated line of best fit, and it is the one line that is exact. Now, the ones that we'll be working with, when we draw them, they won't be exact, but you do have to have sort of a good idea of where to go with them. When we look at correlation, one thing that we're going to look at is strength of correlation. And the way we measure strength of correlation is through the variable r. It's called the correlation coefficient. And you can see on these graphs that, in fact, you can see r squared. Now, that's just simply to account for positive and negative, but the r squared is a measure of the strength of correlation. The stronger these points are correlated, that means the closer the grouping of the points, the closer it is to 1. So r has to be less than or equal to 1. 1 is a line of points. The points are all in one straight direct line. Boom, 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 boom. Right? And that is a perfect correlation. Now, no correlation is 0. So if the points were totally random all over the graph, you would have 0. In these three graphs, you can see the r squared. So the group of points that's least closely grouped together has an r squared factor of 0.6121. So that's not too terribly tight. You can see that these points are sort of loosely grouped around the line. Now, a little bit tighter grouped together, okay, all around the line here, with a few sort of outliers here and there, has a correlation of coefficient of 0.73 or 73%. And this line over here on the right, all these points are almost on the line. So this is very tightly grouped. It has strong correlation, 0.9311. Now, just an adjustment. The correlation coefficient does go up to 1. On the other hand, it does go below 0. It goes down to -1. Now, anything below -1 or below 0 simply means it has negative correlation. Anything above 1 is positive correlation. So a correlation coefficient of -1 is perfect correlation. It's a straight line, but a straight line in a negative direction. +1 would be a positive correlation, perfectly straight line. Here we have a scatter plot that has negative correlation. It's going down. And what we need to do is we need to draw a trend line. So if we just start with a trend line, this trend line, goes through the middle of the points, but it just seems like the angle is off a little bit. It's too steep. It needs to sort of travel in the same direction. So that seems to be the right direction. On the other hand, it's too high. So this is too low, all the points are above it. This is too high. Again, too high simply because more of the points are below. We need to try to get sort of halfway through the dots, but with the right angle. So maybe that will work. Remember, we're looking for both angle to be correct. We're also sort of looking for the middle. Two things when we're trying to get a trend line through the points. once we have this trend line, this line has an equation. It has some slope and it has some y-intercept. This equation tells us how we can approximate all the points. So what we're going to do now is we're going to look at how to get the line of best fit, the equation for that line. So here we have a group of points. This could be any sort of data that we collect and then we want to graph. So what we're going to do is we're going to take this and we're going to graph it. Ta-da! That's how easy it is to make a graph. Amazing, isn't it? Okay, so we're just going to make this graph a little bit bigger so we can see it. And what we need to do now is we need to figure out what the trend line is. Now, when we draw a trend line, because it doesn't have to be quite perfect, you know, there's a range, right? This trend line here, maybe that doesn't work. This trend line here, maybe that doesn't work either, too low. But they're both the right angles. Okay, so the line we want is something like this, perhaps just a little bit higher. Maybe that's a good sort of line. As you do this, you want to think about where you're hitting it. So this line is way too thick. This is all I can do. So let's just work on the upper side of the line. Let's just look at the sort of the top of the line. And when we do this, right, we can think about where we hit certain points. So we don't hit any of the actual points, but maybe we can hit some of the intersections. So if we look at our graph, we want to think about, does it hit here? Does it hit here? And wherever we go, we want to make sure that we actually are going to sort of be in a place where we can get some numbers. So I'm going to say that this point right here is 11, 16. Now, I know it's not quite perfect, but because the graph isn't great, we can use that. And I'm going to use this point right here and call that 23 and 26. Okay, so now we have a trend line. We've hit a couple points on the graph. We need to find the equation of the trend line. Y equals mx plus b. We have 2 points. So this goes back to finding the equation of a line when you have 2 points. So our 2 points are 11, 16, 23, 26. The first thing that we need to do in order to find the equation is find the slope. So let's find the change in the y's, 26 minus 16, and we're going to divide it by the change in the x's, 23 minus 11. So we're using the skills that we did before in order to find the equation of this line. We're putting those skills to use. So our slope is 5/6. Okay, the next step, right, so we have y equals, oh, that's a horrible color. Let's use red. Y equals 5/6 x plus b. We need to find the y-intercept. I would not suggest trying to continue the line far enough to figure out where it hits the y-axis. And the reason is it may not hit at a perfect intersection. It may be between, 7 and 8. And where between 7 and 8? So let's do it mathematically. We have this equation. We need to find b. Let's pick one of these points, doesn't matter which one, to put it in. So we'll use 16 is equal to 5/6 times 11 plus b. Okay, 16, let's make this a fraction, 11 over 1 is 55/6 plus b. Now, the easy way to do this, right, we're going to have to subtract 55/6. I would turn 16 into sixths. So it's 96/6. So now, when we subtract 55/6 from the other side, it's easy to do as a fraction. So we get b is equal to 41/6. Great. Last step, let's go ahead and rewrite the equation. Our slope, 5/6 x plus 41/6. We're done. Okay, we're now at the time where you get to practice this. So we're only going to do one practice problem today. Here's a table. Let's say we measure something. I would like you to go ahead and take these points, right? So there's 6 points. Graph them under a graph neatly, right? Be accurate, be exact. And then what we'll do is I want you to find the equation, right? So after you graph, I want you to draw a trend line. Draw it neatly. Think about which points you're going to draw it through. And then after you do the trend line, find the equation of that trend line. Okay, pause it now and do that. By the way, all that shouting that you heard earlier, that was Joe. Okay, so here's our graph. We're going to take a closer look at the graph. And what we're going to need to do is we're going to need to draw a trend line through this graph. So we want a trend line that is going to look a little bit like this. And again, we're going to just use the top edge of this trend line for the actual line, just because it's too thick of a line. So the way I drew it, I drew it through these 2 points. And that way, I actually have 2 points to refer to. That's 12.21 and 25.5. If you can hit 2 points in your table without, creating a line that's really out of whack, then you should definitely use those 2 points. And here's the really difficult part about this. You may have drawn a perfectly good trend line, but you may not have these 2 points. And if you don't have these 2 points, then your equation is not going to be the same as mine. That's okay. So when we grade, I'm going to grade each one individually. And it may not be this exact one, but it'll be close. So we have 2 points, 12.21. We have 25.5. So we need to find the slope first. We'll find the change in the y's, and then we'll divide by the change in the x's. Again, make sure you go in the same direction. If you start with the top point, make sure you start in the top point with the x's as well as the y's. And if you start with the bottom point in the y's, then make sure you start with the bottom point in the x's. So our slope, 16 over negative 13. Not the nicest fraction, but it's what it is. Now let's go ahead and put that into our y equals mx plus b. We have y is equal to negative 16/13 x plus b. We now have to find the actual y-intercept. Next step will be to choose one of the 2 points. We'll just go 12.21 and go ahead and put it in for my x and my y. Make sure you're putting your x in for your x and your y in for your y. The next step is to simplify before we solve. So we're actually going to do negative 16/13 times 12, which is negative 192/13 plus b. We need to get rid of the negative 192/13, so we'll do the inverse. We'll add positive. On the left side, the easiest way to do this is let's go ahead and change that 21 into 13ths. That is 273/13. We'll go ahead and do that addition problem. And we get 81/13 is equal to b. Great job, all that work, wonderful. Don't forget, last step, we have to replace in the original equation what the actual slope is, negative 16/13, and then we actually have to replace the b, 81/13. Nice job.